It began on the rolling weald of Kent. For the Montebello bomb was designed, and most of it was made, in this quiet, unsuspecting countryside. Behind that screen of trees is Fort Holstead, built for defense against French invasion, now used for research into new weapons and new explosives. The guard on patrol, the check at the gate are not mere routine. This was the headquarters of the man who designed the bomb, Sir William Penny, the only British scientist at the atom bombing of Nagasaki. Britain's leading atomic scientists were then working in partnership with the Americans. But after 1945, they had to work alone, starting afresh with basic calculations to determine the critical mass necessary to produce a chain reaction. Calculations abstruse and complex, beyond the convenient compass of the human mind. But the cells of an electronic brain will solve in a day what a mathematician would take a year to work out. The Montebello bomb and all the equipment for this experiment were made in British workshops by British workmen. Accurate to 1/10,000th of an inch. That was the precision demanded and achieved, both for the bomb and for the instruments to measure its performance. At Fort Holstead, they made 2 high-speed cameras, taking pictures at the rate of 100,000 in 1 second. With these cameras, the scientists could reconstruct the pattern of the explosion in the first revealing fraction of a second. In concept and design, this camera was entirely British, and design became reality in the hands of fine craftsmen. At every stage, check and double check. Instruments too for testing the impact of the explosion, for measuring heat, blast and radiation, for gauging the instant shaft of gamma ray and the lingering poison of radioactivity. All these designed and produced at Holstead, Howell, and other atomic energy establishments. This electronic equipment will carry the circuit to actuate the firing mechanism in the bomb itself. Here, the designer's demands reach the peak of precision, an accuracy of 1/1,000,000th of a second. Nothing was left to chance, but there was still an element of doubt. No one could yet tell for certain how the bomb would perform when the testing time came. Many minds and many hands were turned to the making of this atomic weapon, but only half a dozen knew the whole secret of the bomb's design. They knew they were making a weapon of awe-inspiring power, but they would never see the finished product, never even know, perhaps, the ultimate function of the parts they handled with such care. At Chatham in June 1952, the escort carrier Campania prepares to sail for Western Australia as flagship of a special squadron. Campania once escorted northern convoys, carrying supplies to an allied Russia. And with Campania is HMS Tracker, a landing ship carrying some of the more precious equipment, like this gleaming caravan that houses one of the high-speed cameras. From the broad and busy Thames estuary, HMS Tracker sets out alone for the remote and barren Montebello Islands, lying some 60 miles off the northwest coast of Australia. At Montebello, the advance party is already at work. 200 Royal Engineers had arrived in April to find an empty wilderness of saltbush and spinifex. Parched and stunted, it's readily burned to make way for installations and equipment. And every installation, every instrument, has to be placed by survey in relation to ground zero, the planned point of the explosion. Control points and test buildings rise from the wasteland, but the only local materials are sand and rock for making concrete. There wasn't even a jetty until this one was built by an airfield construction unit of the Royal Australian Air Force. No roads either on these trackless dunes, and the task of building them was arduous and slow. Within the danger zone, they erected the familiar Anderson shelters, well protected by sandbags. And there too, they built concrete structures of varying sizes and strengths to test the impact of blast and the penetration of gamma ray. These tests would influence the pattern of civil defense against some future atomic attack. This was one of the problems Montebello would help to decide. From Montebello back to Portsmouth. There, within sight of Nelson's Victory, Campania takes on the rest of her cargo, a brood of boffins. Physicists and mathematicians, chemists and botanists, doctors and engineers, each with a positive role to play in this great experiment. From Portsmouth on June the 10th, Campania sets out on her long voyage. Campania wore the flag of Rear Admiral Torless, Admiral Special Squadron, the man responsible for the expedition's transport, maintenance and safety. But the Navy has a special interest in this operation. It's intended to reveal the effects of exploding an atom bomb in the hold of a ship in the confines of a harbor like Portsmouth. At sea, the weeks pass slowly on the tedious journey round the Cape of Good Hope. Campania was escorted by HMS Plym. Now she's sailing on her last mission, for Plym is the target vessel, already carrying the bomb in her hold. In mid-ocean, on Campania's flight deck, officers are trained to guard against the hazards of radiation and to detect it with Geiger counters and electroscopes. That box contains radioactive material, giving off radiations which sound like static in the headphones of the Geiger counters. From this crackling, the wearer can tell if the dose becomes dangerous. Campania carries 3 Dragonfly helicopters for rescue, for communications, and in due course for the hazardous task of flying over the target area soon after the explosion and of lifting samples of radioactive water from the poisoned lagoon. Landfall at last, Fremantle, Western Australia. Here the squadron replenishes its stores and is joined by units of the Royal Australian Navy, including the Hawkesbury, a sister ship to HMS Plym. All told, there'll be 10 Australian warships on security patrol around the Montebellos. The squadron arrives on August the 8th, 2 months out from Portsmouth, 2 months before D-Day. And HMS Plym comes to the end of her final voyage in the Montebello Lagoon. Next morning, a party of scientists leaves Campania to explore their island laboratory for the first time, to check the sites for the equipment that will record the effects of the explosion. In their wake comes the equipment itself, taken ashore in landing craft manned by Royal Marine. Stores and equipment go inland. Some by lorry, some by sledge and tractor, for much of the island is treacherous sand. With the aid of bulldozers, some instruments are sunk in the sand as protection against blast. Others stand in the open to measure the blast itself. One gauge is simply made of empty toothpaste tubes, but most of them will relay their readings electrically by landlines that link them to blast recorders safe below the level of the ground. It takes hundreds of miles of wire to complete the elaborate network of gauges and recorders extending throughout the islands that surround the lagoon. Other cables go underwater to control headquarters on another island, so the recording instruments can be set in action at the last minute. Similar cables running from HMS Plym will carry the electrical circuit to fire the weapon by remote control. And when it's fired, these aerials will bring to control headquarters the readings from instruments within the target zone. The high-speed cameras reach their destination. They'd taken months to build, weeks to move, days to sight. But their task would be done in a thousandth part of a second. And now to HMS Tracker, the health ship, the medical headquarters responsible for safeguarding the force against the hazards of radiation. Before D-Day, thorough rehearsals for all those who'll have to re-enter the target area after the explosion. In the health ship, they collect special protective clothing and special devices to record the amount of radiation absorbed. These precautions for every journey into a contaminated zone, so great is the danger from radiation. Every man has to strip and change. They put on fine woolen underclothes, gabardine overalls, sweat rags, rubber gloves, and Wellington boots. By the end of September, all preparations are completed, but the operation has to wait till the weather and wind are right. Meanwhile, there's a moment for relaxation. This is their last chance to fish. After the explosion, all fishing will be banned because of the danger of contamination. October the 2nd, and D-Day will be tomorrow if the weather is right. On shore, these instruments stand like sentinels, waiting to measure the blast of the shock wave. Their measurements will be relayed by line to this recording machine that's now being tested, set and wound, ready for tomorrow. The last sartorial touches are given to those uniformed dummies who'll test the effects of thermal radiation on normal service dress. Rocket projectors are loaded and primed, ready to fire through the deadly cloud rising from the target. These rockets will record the radiation in the air and reveal to the scientists how accurate their calculations were, how complete the chain reaction was. A final check on the Anderson shelters. And on top of one of the reinforced concrete buildings, a scientist sets a shadow graph to record the exact point of the explosion. Boxes of vegetables, sweet corn, lettuce, tomatoes, melons, cucumbers and beans, all grown at sea and now set out ashore to discover how much poison they'll absorb from the radioactive air. Foodstuffs of all kinds await tomorrow's experiment. Butter, tea, tinned meat, sacks of flour, some open to the air, some packed in boxes or cartons or tins, to test the value of various containers as protection against contamination. Here, technicians make their final adjustments to the gamma flux meters, designed to measure the radiation and transmit their findings by landline and then by radio to the control post and the health ship. The stage is set. Technicians, scientists and soldiers all depart from the islands around the lagoon. They're bound for the special squadron, now about to leave for a safe anchorage some distance from tomorrow's target zone. All this time, the waters round the Montebellos are patrolled by the Royal Australian Navy. From the mainland at Broome, Lincoln bombers of the Royal Australian Air Force take off to reinforce the security patrol above and beyond the Montebellos, ranging far and wide over the Indian Ocean. Fine enough here, but the wind is from the wrong quarter, and it's too stiff for easy handling of the small craft. But what's the forecast for tomorrow? "200 miles inland at Roy Hill Station, an Australian meteorologist seeks the answer. The weather and especially the wind must be right, lest the radioactive cloud be carried back to the mainland. Weather reports from Broome. Weather reports from Onslow. A beam to Campania. There, the forecasters examine the reports and charts. The essential conditions are a calm sea, a southerly wind, and no risk of a sudden change. In Campania's wardroom, Admiral Torles and Dr. Penny are waiting for the answer. They've been hanging on the weather for 24 hours already. But the forecasters now see a fairer prospect for tomorrow. In the wardroom, they report that conditions will be perfectly safe. And Dr. Penny gives the order for the weapon to be fired at 8 o'clock next morning. Inside the secret bowels of Plym, one scientist remains to arm the firing circuit. Connect the batteries.